So in the spirit of the open session, I was free to formulate, I just prepared 2 slides with a naive question about the reality of the wave function, which is, I think, close in spirit maybe to what Alyssa Ney said today about the weather physics and the temperature. So I think, my main occupation is being an experimentalist. And while I dabble in foundations, I know many experimentalists who don't. And when we discussed with them about foundation topics, then it's often very, very, very tough for us to convince them that there are foundational problems at all. And I think the reality of the wave function would be one such thing. So I thought we heard many approaches which were a little bit top-down today, which try to construct a consistent theory, how you could formulate the reality of the wave function. And I thought I just pose a naive question. I present how really experimentalists on a day-to-day basis, of which most I think are operationalists, and some of those who are maybe realists, they are probably wave function realists. Maybe that's an inconsistent position, but I think most of them are. So I would like to present the way how they usually use that concept, how they think about it, and I would love to, if some of you could explain to me exactly why this is inconsistent or why this is not a sufficient ontology. So really just a few slides. So there's this thing called the proton size puzzle, where I just have some pictures of how this problem is represented, where people say you have this parameter, the proton size, and then one can do hydrogen measurements on the hydrogen atom. And there are 2 types of measurements. There's spectroscopy measurements, where you basically look at the color of the light emitted from the atom. And there are scattering measurements, like in this picture. So already from this picture, one can see that people have this idea that there's some rotationally symmetrical fuzzy object. And then it's in fact it's a proton charge radius. And I just opened. I'm no expert in atomic physics. So this is from their paper. So, and here is the formula to calculate the spectrum, so the energy of some, it's basic atomic physics, except that you have this part here, which is some quantum electrodynamics correction, but this is the basic quantum state, and then this proton radius, this charge radius comes into telling the spectrum. And then when one looks at this Wikipedia article, there is a formula to calculate the scattering cross-section. And there also one has this, one has the same parameter essentially, the charge radius, and then some laws, some natural laws, and in the end you get directly to this charge radius from some integral over the wave function. It's actually a Fourier transform, so even the phase of the wave function is important here over 3 space. And also my argument would be that in any experimental situation, when you have an object in the lab, it's due to decoherence, you in fact have a 3D object. So my question would be, in what sense is this technically not a correct ontology or inconsistent to try to think that, okay, this psi really tells me, I think of the proton as this psi. If anyone, I mean, in the spirit of the open session. I was just, to me, this seems like a natural way to conceive of what an experimentalist would say is the proton. It's this psi, and all these properties you get from that.
I mean, I feel fine about that, but I think one of the loci of disagreement is going to be, let's grant that defining a wave function for the proton is a useful thing to do and is predictively effective at describing atomic structure. That wave function is probably not a candidate to be the deepest level description of the proton we have in mind. It's going to be, in some sense, it's going to be some sort of emergent approximation in some kind of low energy QCD domain. So then there's a question about how we want to think about our ontology and how relaxed we are about building our higher level ontology in a kind of emergent approximative way from some lower level ontology. So at one extreme, I think you could be really relaxed about that and say it's totally fine to be doing things like recovering the proton level description as some kind of approximative coarse graining over a quark level description, and then by all means retrieving an atomic level description in the same way, and then maybe like a macro level description in the same way. And to one extreme, you could be fine with that. At the other extreme, you could want to say, no, that's clearly not what the world's really like at the most fundamental level. And that's the thing I want to know about. And then this is just a calculational tool. Now, look, I think the first phase is the correct way of running, but I think that's one of the main sort of points of contention in how you want to think about this topic.
I think we should really beware of, really be careful about deducing ontology from mathematics, especially from mathematics, because anybody who knows a bit about math knows that the same thing is represented in totally different ways. You take the wave function, then you have like the Wigner presentation, which is completely equivalent to the wave function. You can make it from the wave function. You can go back and forth between them and not lose any information. So for my metaphysical taste, the presentation is superior. But again, since they're equivalent mathematically, then deducing an ontology from that would be, it's a matter of personal preference rather than any real thing that you say about the universe. The only thing you can say about the wave function is that it's in many cases a very good way of deducing the phenomena, and more than that, and any more ontological commitment than that is just completely subjective.
Okay, thanks. But to me, that sounds like there are other options, so it's not unique, but it's not internally inconsistent or unsatisfactory. If I understand your argument, it's unsatisfactory because it's not uniquely determined. Because there are other mathematical representations which could also be.
Yes. So, yeah.
I just want to make a comment here. Actually, look, I'm not sure what experimentalists think, but if you just go back to your other picture. These pictures, look, there's a picture of an actual sphere there. And then there's a picture of something coming in and exchanging a photon with it and it bouncing off the thing. And if the subatomic world were like that, you could ask, what's the radius of that sphere? Nobody thinks it's like that, right? Nobody does. And then in the next thing you say, well, the proton radius is connected to the momentum transfer and the scattering and the blah, blah, blah. Okay, if you have a number that comes up in scattering theory and you want to call it the proton radius just because it has some mathematical analogy to something you might use in classical electromagnetic that really are local. Okay, that's all it means. It doesn't mean there's an actual sphere there. It means it's just a number that I'm throwing in. And I think, my thought would be, of course, the proton we think has a composite structure. It has some quark structure underneath it. There's a deeper story to where those numbers are coming from. If you're doing scattering theory, there's a deeper story to how scattering works. So anybody who's satisfied with that and says, oh, this is just the proton radius, what's the problem? I don't think it's even a candidate for being the kind of thing that we would think of as a number, even though it's a radius and you can draw pictures of spheres, that there's anything in nature that directly corresponds to that. At least I wouldn't. I think that's just kind of would be a strange, very strange idea. Similarly, the pictures of orbitals, right? What are those pictures of? Schrodinger considered the possibility that literally something is smeared out in a certain shape. And then he got to the cat problem by saying, well, that smearing cannot be kept microscopic, right?
Okay, but I feel like the cat is an extreme example. So to me, but I would think to these experimental physicists, the proton is as real as a chair. So to me, what does a chair mean? A chair means I can bump onto it. So they give, it's a fuzzy bumping. It's not a collision between spheres. And I mean, this sphere is a little bit fuzzy, and I think they think of it as a fuzzy sphere somewhat. Okay, you could also, I mean, but this, I mean, it could be some characteristic. I mean, the line which, I mean, the clam could see some force. It's a charge radius. Could be a charged clam, which is some special force. I mean, I think, and you can also see it. You have the spectrum. You have the emission. You can see its color. So you have several physical properties of this thing which are related to this radius. So, yeah. Sure.
But I think what Jan's saying, that from the experimentalist point of view, we need this wave function, and this is the whole story. And then come philosophers, and they say, no, we need some beables, flashes, Bowman position, other things. Experimentalists don't need them. And the whole experimentalist, this is what's our experience, but a little more precise using devices. So the wave function is whole story. Never mind, it's Wigner function or other thing. It's quantum state. This is all what experimentalists use. No other kind of things. And so if somebody wants to say that the quantum state is not the reality, is a wave function, call it, you know, never mind the name, then somebody has to come with something which will be useful. And until today, I don't see any other proposal for reality but quantum state, which is useful.
How about useful for solving the measurement problem?
No, this is the whole point of this workshop, that the many words solve the measurement problem. It solves it. You can say that the wave function is the whole reality, and this measurement problem is solved. I don't think there is much dispute about this, that many words solves it. People say, maybe say,
so yes, so I think we're going back a little bit to what the point I was trying to make in my talk. So, I mean, I think we're disagreeing about what we want from a theory, right? So you care about what we observe at the macroscopic level. And of course, I mean, there are ways in which you can extract this from the wave function in the way you suggested, right? But if you want a deeper understanding, something that you can explain why we get the measurement result that we get, and we want it in terms of something that we can understand dynamically from the microscopic level, then you can't get it in that way. So I'm not necessarily saying that that's what you should want necessarily, but I mean, that seems like what you are committed to, right? So I mean, he keeps repeating, yeah, I mean, that's all we need in order to get results. Yes, that's right. That's all we need in order to get results. I mean, what if we ask now, where are these results coming from, right? Why do we get these instead of that? Then, you know, you may want to try and do that with the wave function alone. I mean, but then you need all this kind of new machinery that different people have tried differently. And so, I mean, all this business about local beables and having something three-dimensional, I mean, the local, low-dimensional stuff has to do with the kind of desire, the kind of explanation that you need, all right? So, I mean,
yeah. I think I get your point, and I think I also had your talk while I was thinking of this, because, I mean, here you get the proton radius. So you said of more fundamental, to go into a more fundamental, more smaller level. I mean, why, what should be more fundamental, or I mean, why don't I stop at this level? Why do I know I need to have something more? I need point-like particles or something. Why? I mean, I get things like the photon radius. I get the emission spectrum already from this description. Why isn't this sufficient?
Which you go from the wave function to the actual radius of the proton. I mean, you're doing mathematical, you know, massaging of that thing. And so why are you doing that?
It's not direct enough.
Yeah, I mean, I don't understand why that instead of something else. So you have to postulate, oh, I need to do this. Yeah, why? I mean, what's, yeah. And so, I mean, you may be fine by that. I mean, just say, okay, it is because what it is, right? Yeah, so the disagreement is, I think, at the end of the day, something like that. I mean, we disagree about what we want. I mean, talking to lunch, I was talking to him to lunch, you may want, mathematical simplicity of the theory, and so you say, yeah, Everett is great, right? Because, I mean, one equation and that's it, right? But then, of course, you have to somehow, tell all the story, all the complication, all the the long story is gonna happen in the explanation of how you go from this to the rest, right? Instead, other people, like for example me, would be like a little bit of more complication, all right, at the level of, the theory as is written down mathematically, but then the explanation is much more straightforward. But I mean, it's just like, I don't have much more of an argument than just this. Like you have to realize, right? You have to understand what you want, and then act accordingly.
I don't know that, because you said in many words you have this more work to do in this final description, but I don't see like having like another.
Yeah, can I ask a small question?
I think that the Bohmian description is not as simple as the Bohmians try to make it. I think I have some points about that in my poster out there. And so, and also I think that Bohmian seems to me like adding ether. That's really what you're doing. And so it's adding something which has no meaning at all.
Yeah. I wanted to ask a question. I'm a little bit outsider, but I came here to become wiser. But I have some fundamental question. Why everybody speaks about the measurement problem and no one speaks about the preparation problem? They are completely equivalent from, that's how I understand it. I live in a classical world and I want to examine a quantum system. Now I prepare it and then I want to measure the outcome. So I think they are very, very equivalent. Correct me if I'm wrong.
Okay. Maybe I'll explain how I believe that there is no problem with preparation, but now there is a problem of measurement. In 2 minutes, the bus will leave.